If the equation describing the displacement y of an object at time t is either y equals a sine omega t or y equals a cosine omega t, then the object is in simple harmonic motion. In this case, the absolute value of a, the coefficient, is called the amplitude. It is the maximum displacement of the object, how high and how low the object is oscillating between. 2 pi over omega is the period. It is the time required to complete one cycle. And omega over 2 pi is the frequency, the number of cycles per unit of time. Now we have two functions, or two equations. What's the difference between the two? Well, the main difference between the two equations describing simple harmonic motion is the starting point. That's basically the big difference. So at t equals 0, if we use the sine function, we're going to get back 0. If we use the cosine function, when t is 0, we're going to get back a. In the first case, the motion starts with 0 displacement. The sine function starts with 0 displacement, almost as if it's just at rest. Nothing's been done to it, it's just sitting there. Versus the second case, the cosine equation, the motion starts with the displacement at a maximum, at the amplitude a. Again, it's been pushed up to a maximum point or been pulled down to a maximum point. But that's the difference between the two functions. Just where is it starting, at rest or at its maximum? In general, the sine cosine functions representing simple harmonic motion may be shifted horizontally or vertically. In this case, the equations have the form of either a sine of omega times the quantity t minus b and then plus d, or a cosine of omega times the quantity t minus b plus d. The horizontal shift b indicates the position of the object at t equals 0, horizontal shift being left and right, and the vertical shift d indicates that the variation occurs around an average value of d, the vertical shift being up and down. The equations before assume a frictionless environment in which to oscillate. This means that the amplitude of the oscillation will not change. That's not going to happen on this planet and not with physics working the way it is. There's always going to be some kind of friction. So how do we do that? Well, in the presence of friction, the amplitude of the motion will decrease over time. This type of motion is called dampened harmonic motion. So, if the equation describing the displacement y of an object at time t is either y equals ke raised to the negative ct times sine of omega t, or y equals ke raised to the negative ct times cosine omega t, where c is positive, then the object is in dampened harmonic motion. The constant c is the damping constant, k is the initial amplitude, and 2 pi over omega is the period.